Number 7 on the applications worksheet. A miniature golf hole, 3 meters wide and 8 meters long, consists of a wall in the shape of an ellipse.
A miniature golf hole?
With both the tee and the cup at a foci. Okay, there's my golf hole, like the top view of it. It's 3 feet across. I guess I could have put that in here, and 8 feet long. So that's oh, it is meters. Thank you. That is very large, yes. 10 feet by 25 feet. With both the tee and the cup at the foci. So I don't know where the foci are, but one focus, the other focus. A golf ball hit in any direction will bounce off the wall and roll into the cup. That's a true statement. If it's a perfect focus and if there's not any, bumps in the grass or the artificial turf, if any ball hit from one focus will bounce off the wall and land at the other focus.
So if you hit it behind it, it'll do that?
Yeah, even if right? That would be the obvious case because it would just bounce straight off and head toward the... You'd have to get the speed right. And if the tee was, elevated or whatever, it'd be a problem. But just generally speaking, the two foci, the focus of the problem, you hit it at one, it'll bounce and land on the other. All right, find the equation of the ellipse, which describes the hole. Well, that's what we're supposed to do first anyway. So we'll put the center, or put the origin of the graph at the center of the ellipse. That way we don't have to worry about x plus h and y minus k. So x squared over something plus y squared over something equals 1. And the somethings, let's see, so what's going to go underneath x? A squared, yes. What's a equal to? 4. So another one where they didn't quite give you what you need. They gave you enough to figure out what you do need. So 4 squared would be 16. And under y would be 1.5 times 1.5. Or you could just leave it as 1.5 squared if you wanted to. Again, you got a calculator so you can multiply it out. But if it's easier and it kind of makes more sense to fit the problem, you could just leave it as 1.5 squared.
Wait, is 1.5 the half of 3? Is that what you meant?
Correct. So that B distance is 1.5. How far apart are the tee and the cup? Tee and cup. So in terms of ellipse variables, how far apart are the tee and the cup? How far apart are they? Not with the number because I don't know that yet, but in terms of A, B, and C, how far apart? How far is T from the cup? 2 little c. That's a good answer. Not big C, the center, but 2c. Because C is the distance from the center to a focus. So center to focus and center to focus, I got 2 of those. So C squared equals A squared. Oh, this is what I was talking about earlier. For an ellipse, minus, because it's always opposite of the main sign. That's how I remember it. C squared equals 16 minus 1.5 squared. Again, I'm going to the calculator to let the calculator handle all these decimal stuff going on here. Square root 16 minus 1.5 squared. 3.708 meters. Be careful, that's not the answer. right? You kind of get lost in the details of the problem. And I need to multiply that by 2. So that would be 7.416 is the distance between the tea and the cup. Which makes sense in terms of the picture. That's the one nice thing about the word problems, is that if you get an answer that doesn't make sense, you can probably catch it. Like if we had done plus right there, then our 2c would have been more than 8. And hopefully you would have realized, well, wait a minute, that doesn't even make sense. So with the word problems, you can kind of use a little bit of sense with your answer to see if it looks right or not. And that one looks okay. It means my foci are a little further apart than I drew them, but at least they're still within the circle or the ellipse.